jumping back into part 2 of the extra math 2 from the HubSpot tests. We did part 1 yesterday. Excellent problems. Make sure to check that out. Let's jump into number 20 here. So again, I see a system of equations. I see variables, so I know it's going to be one of those more unique problems. But instead of no solutions, I see infinitely many solutions. So a little bit more unique, but there's still going to be a systematic approach. I want to set my two equations equal to each other somehow. When there's infinitely many solutions, that means it's the same line. They all have the same points. So how could I set these two lines equal to each other, right? And we should be thinking multiples maybe. So let me write down my bigger equation here. I'm going to write down my 2x plus 8y is equal to 60. And ask yourself, what could I do to the other equation to make it equal to this one? And it's going to be multiplied by 5. Because if I multiply that right side by 5, I should get 60. So this would turn into 5ax plus 5by is equal to 60. So if their right sides are equal, their left sides have to be equal, right? Their x's are equal to each other. The y's are equal to each other. And now all that's left is 5a has to equal 2. And then 5b has to equal 8. I look at the, the conclusion of the problem to kind of see the direction they want me to go in, and they want it a over b. So I do the same thing. I do, okay, 5a over 5b, and that's going to be equal to 2 over 8. The 5's cancel out, a over b, and I just reduce this fraction. I should get 1/4 here, and 1/4 is going to be the right answer. So not too bad. Infinitely many solutions. Find a way to set them equal. That's all you have to do for that one. Let's go ahead and scroll down to our next one, number 7. So this is a good practice problem here. This is, one we could obviously throw in Desmos. Anytime I have a function and they're asking me to, maybe this is going to be like, hey, what's this in vertex form? Or hey, what's this in parenthesis form, right? I throw this into Desmos real fast. And, oh, nice, I already have it. So we have this in Desmos. There's going to be multiple things I'm looking for. So if they're asking for, vertex form, which we'll kind of get a better idea of what that looks like, I go to my vertex here, the 3, 1, where both my lines converge, and I jump back to my problem here, and I say, okay, if my vertex was 3, 1, was that -1, I think? If my vertex was 3, -1, what would my equation look like, right? Remember, the vertex form of our equation, or our quadratic, is always going to be in parentheses the opposite of the 3. So it's going to be x minus 3. And then we're going to have a squared up here. And the -1 goes on the outside. So straightforward on the outside, opposite on the inside. So right here, I see x minus 3 squared. And then they just threw the 1 on the other side to try to be tricky. If I minus that over, I would get that. So B would be if they were looking for vertex form. Let's see if we identify another one here. This looks like they just took standard form and just minus the 8 over, so that's not going to help me with anything. This point slope form, I don't think they're going to be asking for that on this test, especially for a quadratic. And then finally, this looks like it's going to be maybe my solution form, or rather parenthesis form. So let's see what our solutions are on this graph real fast. It looks like they're going to be 2 and 4. So if I write those down, x equals 2, x equals 4. So I would consider that solution form. If we want to put that in parenthesis form, we just go backwards a step. I get my 2 parentheses, and I say x minus 2 and x minus 4. And it looks like that's going to be D. So B and D are both different ways of expressing our function. And let's see which one they want. Which one displays the x-intercepts of the parabola? Well, I know that's going to be D. That's going to be kind of like intercept form. B is going to be vertex form. Not too bad. Jumping down to number 8. Looks like these guys are playing a video game. Let's see what we got. So each player starts the game with K points. Okay, so that's my start. And we lose 2 for each time a task is not completed. So maybe like amount of tasks. If a player who gains no additional points, so there's no K plus, and fails to complete 100 tasks, so that's going to be K minus 200, because this I would just plug in 100 for, equals 200. Well, that's pretty easy. It looks like K would have just been a start of 400, right? And what is the value of k? Yeah. So these, just follow the context of the problem. You saw what I did. Label it out nice and organized, and it's not too bad. Let's look at number 9 here. Another word problem that they're turning into equations, but they give us a little bit of help here. Okay, so a worker uses a forklift to move boxes that weigh either 40. So I've seen this problem 100 times. Hopefully, if you've gone through my other worksheets, you've seen this type of problem 100 times. 40x plus 65y. I already know that's going to be that type of problem. And there should be a total amount of pounds. 2,400 pounds. So less than or equal to, I'm guessing, there's going to be like a weight capacity here. And I look through my equations and I already see A is good and D. I think those are my only 2 options so far. Let's look at my second equation. Up to 45 boxes. So I know that's going to be X plus Y is less than or equal to 45. And again, I look at this equation, I look at that equation, that's going to be wrong. It looks like A for number 9, and that is true. So not too bad. I went a little faster here with the equations because, again, this is my 9th worksheet in. There are so many of these derive your own equation problems. Even when they lay them out for you, it's still a better strategy to derive them yourselves. Not too bad. You have your weighted equation up above. That's with all the coefficients with x, y. And your simple equation below, that's you're always going to have an x plus a y something on the other side. And number 10. This is a decent one. Let's look at 10. So number 10 says f of 2 is 3, f of 3 is 5, and then we have g, f of 3 is 2, f of 5 is 6. So what is the value of f of g of 3? So we know g of 3 is 2, right? So it's going to be a little bit of substitution. So for g of 3, I'm just going to substitute in 2. And then f of 2 is 3. So honestly, make sure that's right. Yeah, that wasn't too bad. So those are just making sure you're kind of following what we're plugging in. Not too bad at all for 10. Kind of on the probably easier intermediate side. 13, I love these. These are the statistics problems that are always going to have the same way of solving them. If you've watched the other worksheets, you know the word I'm looking for. Let's see what they ask. They conducted a survey in a certain large town, prefer watching sports on television to attending the sporting event. So watching it on TV versus attending it. Okay. So the researcher asked 117 people who visited a local restaurant on a Saturday. Any red flags? They're asking people about watching sports on television, and they went to a restaurant on a Saturday to ask this. Okay? 7 people refused to respond. Remember, this doesn't ever mean anything. People refusing to respond doesn't matter. That doesn't ruin your stats for the survey. Which of the following factors make it least likely that it's reliable? So again, we're looking for that word bias. What was the bias here? It's just like they went to a sporting event to ask people if they prefer going to sporting events, right? Those people would mostly say yes. On a Saturday when it's game day and they're asking people if they like watching sports on TV, most are going to say yeah. Sample size and population size, they're not going to test that on the SAT. Those are always wrong. Where the survey was given. Perfect. C, we already went over. That's not going to be another thing that they test you on. Always about the bias, and it's going to be where it was. Great problem. And this one is a really interesting one. I love this problem. I think it's very unique. I've only seen it once. Let's kind of go over what's going on here. I'm going to move this over a bit. Okay. So a survey was taken about the value of homes in a county. Okay. And it was found that the mean home value was 165,000. So that's mean. And then we have another value here. The median was 125,000. So let's try to set up a graph here, right? So I'll set up right at the bottom here. And it's easier to kind of show our median because that's our middle number, right? So if this guy is 125K, let's try to make this really simple with our data points. Let's say that there's 101 total houses, right? So that's the number. So a median of 125K would mean that 50 houses are on this side. Oh, you can't see it right here. 50 houses are on my left. 50 houses are on my right. And then one single house, that's going to be my median. That's my 125K. So I think it's really easy to imagine the perfect problem. That would be where my median is 125K and my mean is 125K. That'd be the perfect world, right? So let's look at it when it's like this. The only thing that's ever going to change is my mean can sometimes be bigger and my mean can sometimes be smaller. So what would that mean if my median, and it's in this problem, or sorry, my mean is bigger than the median? And this is where we want to think, if I have a bunch of 125Ks to my left, right? All 50 of these data points, 51 of these data points technically, are all 125K. Well, in the world where the mean is 125K, everything on the other side is also 125K. But imagine the world in which these 50 are actually much higher. Imagine these are all 240K. These 50 homes are 240K. So what that would do is my middle number, right? 51 homes are still 125K. My middle number, my median would still be 125K, but my average, my mean shoots way up to 165K because I have this minority of houses that are much more expensive than the median. So just for the sake of this problem, let's look for that answer, and then we'll kind of explain the opposite side, but it's systematic. You could probably explain the opposite side to yourself. Let's see what our answers look like. The homes have values that are close to each other. That just seems like a misleading answer. That seems like one of those ones that you could kind of always disprove, even if your median and mean were equal, because you could still have a dollar home and $1 million home and then have it average out to be your median. There are a few homes that are valued much less than the rest. That might be something. There are a few homes that are valued much more than the rest. That might be something else. Many of the homes have values between 125 and 165. That is like A, where we could just disprove it. There could be a dollar home and $1 million home, and we can manipulate the mean and median however we please doing that. Which of these is the answer now, and which of these is the answer when they ask the opposite, right? And it's going to be, for this case, we kind of outlined it here. There are a few homes that are valued much more than the rest. So when the minority has a much higher average than the rest, that's where we're going to get a higher mean than median. That's going to be C for this one. And then B is just going to be when they ask the opposite. B is going to be when they say, not 165, say that our mean was actually 85K and our median was 125K. In that case, I'm going to have a ton of homes on the left side that are maybe worth 50K. And that brings, even though my median, the middle of my houses, hits 125K, I have so many of these lower valued houses, it brings my mean down to 50 or to 85K. So this is going to be the opposite of what they're asking in number 18. So not a bad problem, very unique. This is going to be part 2, and we're going to jump into a lot of good problems next time.